Okay, same again. We're not drawing a graph this time, but it's back to the max min type question. So first thing we do, we get it into our wave function. Right? This time I'm just going to jump straight in. I'm not going to put the headings. Oops. And the minute I do that, I make a mistake. Hard to talk and write at the same time. Okay, and then rewrite it. Fantastic. So I've moved the sine alpha to the front and the cos alpha to the front, and then I'm going to equate that with the question. So I've got root 3 sine x plus cos x. So it must be 1 cos x. And then you're just saying, okay, cos's match up, sines match up, pluses match up. That means that this has to be exactly equal to this. And this has to be equal to this. So k sine alpha is equal to 1. K cos alpha is root 3, which means that tan alpha is 1 over root 3. So alpha will be equal to 30 degrees, and it is in degrees because of this. So you can do that with your exact values. Maybe that that might come up on another question, so remember your exact values. But you're just doing shift tan 1 over root 3, and that'll come out as 30 degrees. If you want to just double check for this one, I would just draw it every time. But we should know by now that I've got sine, cos, and tan. They're all positive. So sine is positive here, cos is positive here, tan is positive here. So I don't have to change the alpha. Okay, if one of these was negative, I would do something different. And again, when you're doing this sum, don't forget you're always doing inverse tan of the positive. Whatever this is, you would do the inverse tan of the positive, and then use the CAS diagram to sort it. Okay. And I'll do my k value. So k is equal to 1 squared plus root 3 squared square root, regressive square root. So that's root 4, which is going to give me 2. Looks very similar to the last question so far, doesn't it? And my final answer then is going to be 2 sine x plus 30 degrees. Fantastic. Okay, now that was the same. I'm actually just, you know what, it looks really weird without this bit. I'm going to have to just throw that in. Expand, equate your k. And don't, you can do this in your exam. Sorry, that's tan, sorry. Alpha. You can do this in your exam to kind of help the marker show what you're doing. It's absolutely fine. I'm sure they'll enjoy that. The neater it is, the better. And this time, so very similar to last time, but now we're doing finding the maximum value of this. So what we want to say is, for part B, that 2 sine x plus 30 is equal to root 3 sine x plus cos x. Yeah. So I rewrote this in this form, so I know they're equal to each other. And now what I'm saying is I'm trying to find the value of 5 plus root 3 sine x plus cos x. So what I've done to get from here to here, well, I've added on 5. So now I have to do the same in mine. I have to say, okay, plus 5. So that's going to give me 2 sine x plus 30 plus 5. Yeah. Well, I'll do it to one side, do it to the other. So what is the maximum value of that, and where does that occur? Well, let's look at our max and our min then. Just in case that came up. If it wasn't for the 5, the maximum would be 2 and negative 2. But now I'm adding on 5, aren't I? I'm moving the whole graph up 5. Yeah. So my maximum is going to be 7, and if asked, the minimum would be 3. So that moves the entire thing up. So over here, we're saying the maximum value is 7. And then where does that occur? Well, where is 2 sine x plus 30 plus 5? Where does that function equal 7? If I rearrange that, I'm taking away 5 and dividing by 2, so I'm just left with sine x plus 30 is equal to 1, i.e. the maximum. Where's my sine function at its maximum? Okay, well, let's have a think. That is my sine function at maximum. It's maximum there at 90 degrees. So if I do inverse of sine, I'm going to end up with this is equal to 90 degrees. But I've moved it over 30, so I have to take off the 30. So that's going to be 60 degrees. So I quite like that question, just to show you a slightly different take on this bit, just to remind you. Yeah, this bit was similar to last time, but visualizing your graphs is quite important in this for these second bits. There's only 2 marks in that. It's not a lot, really. A bit sad, so you might get 3. I think now you're maybe getting 3, but yeah, not too bad a question. Definitely working out the max. I suppose you 1 mark for this, 1 mark for this, fair enough. But yeah, that's a nice little mark to have. Surely we can get that. If you're not sure about this bit, if you look at it, I'm sure it makes sense. But definitely don't be stressed out about working out a maximum or a minimum. It's just the front number, and in this case, we added on 5. So that is, and the last one we'll do with graphs. So remember, we drew them in as well, the whole thing, and also we were equating our graphs, and this time we had to times them by 3 to get the max and min. So that's our 2 main skills so far, is drawing the graphs and solving the wave function. So we should be getting really good at our wave function now, and just the solving part, similar to the max and min. Instead of putting the max and min in there, you're putting a different number in. When does your function equal this number? Okay. The max and min one is putting equal to the maximum or the minimum value. Is exactly the same. So if anything, the max and min is easier because you don't have to worry about your CAST diagram. You just have to visualize your graph. So if you visualize your graph and say, well, if I do shift sine, it's going to be this point. Simple as that. Same for cost. Well, where's cost minimum? Okay. Yeah, so the next couple of videos, I think we'll look at just slightly trickier questions, ones that I picked out, a wee bit wordier, and yeah, that'll be us finished the wave function.